All right, today we're going to use matrix operations and in particular row reduction to discuss what happens between two lines. Okay, so in the past we had saved this sort of process for when we were talking about planes, but our book with the new curriculum now introduces it a little bit earlier, which I think is intriguing. So we'll see how this goes. This, I hope, is a review of Algebra 2 for you. But what we can do is we can take this system and put it into a matrix. Okay, what I've done is I've taken the coefficients, and so I've got all my x's in one column, all of my y's in another, and my constant, whatever it equals, on the other side. And our goal is to get as close to this as we can. Okay, this would happen, then if we do, then what we have found is that our 1x equals a and our 1y equals b. This would tell us that x equals a and y equals b. So then we have solved for this, this system. This particular problem, I cheated, I looked ahead in the book. This is an example in the book. It doesn't work out quite so nicely, so we may just get to this. I'll show you what I'm talking about. So the first thing, notice what we want to do is we want to get a 1. And so this is our first step, is to get a 1 in that top corner. And then the second goal is to get a 0 here. So that was what I would do second. Then the third thing I want to do is get a 1 here. And then I'll use that to get the corresponding zeros. So 0 in this case. So the first thing here, when I look at this particular problem, I try, well, what I can do, a review from Algebra 2, is I can swap rows, I can multiply through by a row, and I can add rows. So I can multiply and then add if I want to. I can't add the same thing to each spot. So think about it, when I'm dealing with this equation, I can multiply through all the way through by a constant. But I can't just say, well, just because 3x plus 5y equals 9, that doesn't mean, if this is true, 3x plus 5y equals 9, it does not necessarily follow that I can add 2 to each term, and therefore 5x plus 7y equals 11. That's not true. And so in the past, I've seen some of my kids do this sort of thing where they try and add the same thing to each element. You can't, okay? Just because you know this to be true, you could then say, well, okay, 6x plus 10y equals 18. That follows. If this is true, then that is true. But this does not. So notice we can multiply this whole row by something, but we can't add the same thing to it across the board. You can add rows, just like you could add, so basically what we're doing is we're taking the elimination method for solving systems and putting it together with this row operation. So anything that's true for elimination is still true here. Okay, so what they did in the book is they went through, and what I'll do is I'm going to leave row 2 alone. Off to the side, I like to describe what I'm doing. I'm going to multiply row 1 by 1/3. And the advantage of that is that now I have a 1 right here. Okay, so 1/3 of 3 is 1, 1/3 of 5, well, that's annoying, but it's 5/3. And then 1/3 of 9 is 3. So I like to write it off to the side in case I mess up later, and I can go back and say, what the heck did I do? Okay, I tried to take this row 1 from before, multiply it by 1/3, and that's the new row 1. Okay, now my goal is to get a 0 here. So if I multiply row 1 by 2, and then, or negative 2, and then add it to this, then I can, a negative 2 plus 2 gives me 0. So I'm going to keep row 1. And I'm going to say, okay, a negative 2 times row 1 plus row 2, and that's what I'm going to replace here. Or, well, replace here. So negative 2 times row 1 is a negative 2 plus 2 is 0. Negative 2 times this, that's a negative 10/3. And this is negative 9/3. So negative 10 and negative 9 is negative 19/3. And then I have negative 2 times row 1, that's negative 6, plus negative 6. It's too early in the morning for me, you guys. I'm sorry. That's, I think, negative 19. Yeah, okay. And now what I want to do is I want to make this become a 1. Well, because that's my goal right here, right? Well, what I can do is okay, I'm going to hang on to row 1. And I can say, okay, well, if I want to make this a 1, I can multiply this by negative 3 over 19 times row 2. So then this, okay, negative 3/19 times 0 is still 0, which is why we like to get the zeros. If you get zeros and then you start multiplying by stuff, they stay 0, which is great. Okay, and now negative 19 times a negative 19 over 3 times a negative 3 over 19 becomes a positive 1. This, oh, isn't this lovely? The 19s cancel, the negatives cancel, and this becomes a positive 3. Okay, so what we know at this point is that our y value is equal to 3. So we could go ahead and try and get rid of this value, but it might be a little annoying. What they did here in the book at this point is they said, okay, well, x plus, this top row means x plus 5/3 y is equal to 3. Well, we just discovered that y is equal to 3, so we can say x plus 5/3 of 3 is equal to 3. So x plus 5 is equal to 3. Subtract 5, x is therefore equal to negative 2. So what we have done is we have found that these two lines both have in common, or they intersect at the point negative 2, positive 3. Okay, and that was a little refresher. Hopefully you've seen this before. If not, let me know, and I'll try and find you more resources to how to practice this. We are, HL, when we get to planes, this gets beefed up a little bit, so make sure you know what you're doing here. Then what they suggested, or then the next problem is use row operations to solve this. Notice the difference is that there's now a variable. Okay, so I'm going to take this 1, 3, 5, 4, 12, k. Okay, I already have the 1. That's great. Let's get rid of this. Let's make that a 0. So what I'm going to say is I'm going to keep this 1, 3, 5. I'm going to say, okay, a negative 4 times row 1 plus row 2. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 3 is negative 12 plus positive 12 is 0. Negative 4 times 5 is negative 20 plus k, so this is k minus 20. Okay, now notice what we have here. We've got two zeros. So what this is telling us is that we have, well, 0x plus 0y is equal to k minus 20. Okay, what are we saying here? We're saying 0 is equal to k minus 20. So notice on this one, we're not getting our two lines to intersect at a particular point. We didn't solve for a y value equals something. We have 0 equals, well, k minus 20. So what happens is that when k is equal to 20, we end up getting 0 equals 0, which is true. Okay, which tells us we have a true statement. 0 equals 0. It tells us we have a true statement. That tells us that our lines are, it's the same line. I think they use the word coincident. So if k, when k is equal to 20, the lines are the same. Line 1 and line 2 are, I can't spell this early in the morning, coincident. Okay, they're the same line. Well, let's look at that. If I had this, x plus 3y equals 5, and then when k is 20, I have 4x plus 12y equals 20. All I've done is taken this first line and multiplied it by 4. 1 times 4, 3 times 4, 5 times 4. This is the exact same line. So yeah, it's the same line twice. Then we can also say, well, either k is going to be 20 or k will not be 20. Okay, when k is not 20, then we end up getting a false statement. Okay, when k is not 20, we get 0 equals something else that's not 0. And that tells us that our lines don't intersect, because what's going to happen here, we're just in 2 dimensions, and so either our lines will intersect in 2 dimensions, or if they don't intersect, they have to be parallel. Okay, so, and if you look at this, so if it's not 20, then that's saying we've got x plus 3y equals 5, and 4x plus 12y equals something else, I don't know, 17. My birthday is the 17th. Okay, whatever. So now what I notice here is that I have the same slope between these lines, but different y-intercepts. So I can prove it to you. This has what is the slope? Negative b over, wow, it's too early in the morning. So I have y is equal to, subtract that, that's a 1, negative 1/3 x, plus I don't really care. Okay, maybe I do care, plus 5/3. And over here, then I have, what, 12y is equal to negative 4x plus 17, divided by 12, y is equal to negative 1/3 x plus 17 over 12. Notice those slopes are the same, but the y-intercepts are different. Okay, go practice some of these. Good luck. Let me know if you need additional practice with matrices. This will come back when we get into planes. So let me know, and I will do what I can to support you.